Hey folks, in this video we're going to be learning about data types and data frames in Python's Pandas data analytics library. This is my second breakout video from my fundamentals video for beginners. So we're going to be building on top of the last lesson that talked about dictionaries and lists. So if you didn't check that one out and you want to learn more about these fundamentals, I'll have that linked in the description. We're going to be moving a bit quicker today. So if you are looking for a more thorough explanation of fundamentals and a broader look at fundamentals, then I suggest you check out my Python Pandas for Beginners video, which is also going to be linked in the description. So we're going to start coding. I'm going to be using Google's Collaboratory Notebook, which is Google's version of a Jupyter Notebook. You can use whatever IDE you want to. The code that we use today will work regardless of the tool that you decide to use. So I'm going to begin by renaming my notebook to data types and data frames. I'm going to manually engage my runtime, and I am going to create a text cell that says data types. So I thought it'd be good for us to begin with data types because that is what data frames are built out of. So this isn't going to be an exhaustive list, but this is going to provide you with a brief explanation of some data types that I think you'll likely have or you'll likely be working with if you are a beginner. The first is a string. So I'm going to declare a variable of x, and I'm going to set it equal to single quotes, and then I'm going to type in some letters. So this is effectively a string. You can do single quotes, you can do double quotes, doesn't matter. The recommendation that I would give to you, though, is that you remain consistent within your script. So if you're using single quotes, use single quotes. If you're using double quotes, use double quotes. Try not to mix and match them. I would like you to know that, if you're working with a phrase with an apostrophe, you'll likely want to use double quotes. The reason for that is that if you use single quotes for a statement like this isn't going to work, you'll notice that the string ends, and that's because the environment thinks that the apostrophe is the closing single bracket, right? So you can see here, I'm adding another single quote here, and it's still not acknowledging these letters over here. You can see they're outside of the string. That's because it thinks this is a new string, right? So it thinks that like these two things are different. So what I would recommend in these situations is using double quotes. That's how you'll fix that. That way, this apostrophe is seen as a unique instance, and the string is encapsulated by double quotes. But generally speaking, if you can, remain consistent with your formatting just as a best practice. The next data type that I think is important to know is an integer. So an integer is a whole number. I'm going to set my integer equal to variable y, and it's just going to be 10. In addition to integers, you'll have float values. Sorry, I'll spell that right. You'll have float values, and I'm going to set mine equal to variable z, and that's just any integer that has a decimal point. So if you don't have a decimal point, it's an integer. If you do, it's a float. The final data type that I want to touch on is our dates. So I'm going to set my date equal to A. I'm going to do single quotes. I'm going to do 2024-01-01. There's a lot of different ways for dates to be represented. They can include time and all, hours, minutes, seconds, milliseconds, all that type of stuff in there. They could be formatted with month, day, year, or in this case, we have year, month, day. Different places around the world format dates in different ways, which makes them a challenging data type to work with. It's once you kind of figure out some methods for managing them, it's a little bit easier, but they are challenging. They generally take more massaging and you have to be more articulate with them than if you're working with a string or an integer and a float. I think I'm going to make a video just about dates at some point, because it really doesn't matter if you're working in Python or SQL or in a spreadsheet. Dates are difficult because of all that versatility or volatility that they have. Cool. So now we're going to move into working with data frames. So this is going to be building directly on our last lesson because we're going to be building them out with dictionaries and lists. So before we can work with data frames, we have to import pandas. And we are going to cast pandas as PD. And you'll notice that my environment is actually recommending that I cast pandas as PD. It's generally a best practice to have pandas as PD. I think it's just easier throughout your script to type PD when you want to reference the pandas library versus typing out pandas every single time. So if you are working in a notebook environment like I am, make sure you run your cell to activate pandas, or the cell with the pandas import in it. I'm going to add another code block, and I am going to build a dictionary. So I'm going to set this equal to a variable called combo, and I'm going to begin by using curly brackets. I'm going to hit enter, I'm going to use single quotes, and I'm going to denote a key of person, and then I'm going to use a colon. I'm going to start building out a list. So the way that I build out a list is by using square brackets. Person is only going to have strings in it. So I'm going to use, and they're all going to be comma separated. So we're going to do single quotes, Joe, comma, single quotes, Joan, comma, single quotes, Phil. We're going to go to the right of our list, and we're going to use a comma. We're going to hit enter. We're going to have a key called date. We're going to have a colon, we're going to do a space, and then we're going to do another list. These will also be strings because we're going to be passing in dates with year, month, day formatting. So I'm going to use single quotes. I'm going to do 2024-01-01. I'm going to go to the right. I'm going to use a comma. I'm going to use single quotes again. I'm going to pass in 2024-01-15. I'm going to go to the right. I'm going to add a comma. One more single quote. We're going to do 2024-01-25. We're going to go to the right of our list. We're going to add a comma. We're going to hit enter. And now we're going to pass in another key called amount. We're going to go to the right. We're going to add a colon. We're going to add a space. We're going to have another list. Now amount is going to have integers. So we're going to pass in 15, comma, 25, comma, 35. We're going to go to the right of our list. We're going to add in a comma, and then we're going to add in one more key. And that key is going to be called rate. We're going to go to the right of our single quotes. We're going to add in a colon, space, square brackets, and now we're going to pass in floats. So I'm going to pass in 5.1, 10.25, comma, 13.24. So when we print this, you'll notice that we are returning our dictionary, right? So we have our curly brackets, we have our 4 keys of person, date, amount, and rate, and then we have our values that all appear in lists. So what we're going to do now is I'm going to remove that print statement, and I'm going to pass the dictionary into a data frame. So we're going to declare a variable of df, which is short for data frame, and we're going to set that equal to pd.dataframe, and you'll notice that data frame has a capital D and a capital F. This is case sensitive, so if you do not have that spelled that way, you're going to get an error. We're going to use parentheses, and then we're going to pass our combo variable into our data frame method. We're going to hit enter, we're going to type print, and then we are going to print our data frame. And now check it out. Instead of returning our dictionary, we now have rows and columns that represent the data that we put into our dictionary. I also want to point out that our rows are 0 indexed. If you watched my previous videos on lists and dictionaries, you'll know that lists default to a 0 index. It is the same thing with our data frame. Now you can't tell because we have keys, but the columns are also 0 indexed, which you'll see in a moment. Now, before we move on, I just want to show you how to reference individual values in your data frame. So for example, if we wanted to call out the person column, we could add a square bracket next to df, pass in a single quote, and now you can see each of our keys are suggested. So now we can select person, or we can type person, and if we rerun our cell, you'll see now we're just returning the person. And you'll also notice that we're getting a data type, right? So you can see D type, we're getting object. Basically, we're getting a string object. I am going to now pull in amount, and then you'll see that that should give us int 64. Yep. So you can see here, we're getting the data type of our column, which is called amount, and it is an integer. Cool, so I'm going to remove that, and then I'm going to rerun with just our data frame. So as I noted, our rows are 0 indexed, but our keys have, our columns have our key values. I'm going to comment out my data frame there. And now what I'm going to do is show you what happens when we pass lists into our data frame. So we're going to build a list. So we'll call this list _1, and we'll set it equal to square brackets. And then I'm going to hit escape because I don't want those suggestions to populate. I'm going to hit enter, and then I'm going to pass a list. So when we're working with a dictionary, we can have key and value pairs. So that means that person, date, amount, and rate can be associated based upon the position that they fall in the list, and they will be associated with one another. When you're building out a list, you can't do that, or at least in the example I'm going to give you, you can't do that. So what I'm going to do now is I'm going to build out a list with a single quote for Joe, and then I'm going to do a comma, and then I'm going to pass in the date, and then I'm going to do a comma, and then I'm going to pass in the amount, and then I'm going to do a comma, and then I'm going to pass in the rate. So you notice we have a string, a date, a integer, and a float. So then we're going to do a comma, we're going to hit enter, and then we're going to pass in a string for Joan, comma, and then we're going to pass in the date that we associated with Joan, which is 2024-01-15. We're going to do a comma, we're going to pass in an integer of 25, and then we're going to pass in the float. We're going to do a comma, and we're going to do one more for Phil. So we'll do another list, and we'll do Phil in a string, and then we're going to give the same date that we used above, which is 2024-01-25. We're going to do a comma. We're going to pass in his integer of 35 as well as his float of 5.1. So we're going to print list _1. And now you can see we're getting a 2-dimensional array, which is also known as a list of lists. So I should actually correct this. My apologies. We learned how to build a list of lists. And the reason that it is a 2-dimensional array is because your first dimension is the list, and the second dimension is the point that the value is entered within the list. So if you wanted to get the first list, you would pass in list1 square 0, and you can see we're getting Joe. That is dimension 1. And then dimension 2 is the point in the list that we want to access. So if we wanted to get the first value from the first list, we would do list _1 square bracket 0 square bracket 0. Cool. So now that we have this list of lists, we can also build a data frame from our list of lists. So what we're going to do is the same thing. We're going to do df _list, and we're going to set it equal to pd.D data F frame, and then we're going to pass in list _1. Oh, my apologies. We're also going to print df _list. And check it out. We now have a 0 index data frame, and because we don't have any headers or any keys, you can see that the columns are also defaulting to 0 index. So if you wanted to add headers like you do from your dictionary, all you have to do is add in another list. So we're going to go back up to our list of lists, and we're going to hit enter. And we are going to add a comment and say create headers. And we are going to save that to a variable called headers. And we're going to set that equal to a one-dimensional list. So we just have a list. So we want our first header to be single quote person, comma, date, comma, amount, comma, rate. And you'll notice these are all strings. So what you can do now is you can leverage the DataFrame function by defining that list1 is your data. So you're going to say data is equal to list1. And then you're going to go to the right of list underscore 1, and you're going to add in columns is equal to headers. So when we rerun our cell, you'll now see that we have headers in place of our 0 index. So that's a really cool thing about Python, and specifically the Pandas library, is that you have robust functions that give you a great deal of versatility with how you can transform your data, right? So it doesn't matter if you have a list, it doesn't matter if you have a dictionary, you have the ability to take the information that you have and then turn it into what you need. Now, the last thing that I want to show you is you'll notice earlier when we were exploring our dictionary, when we were identifying, and we should be able to do this with our df list, when we did df amount, for example, that we returned the name of the column as well as the data type of the column. This is learning the data type of your data frames is a very helpful tip or tool that you can leverage when figuring out what you need to do to transform your data to get it to do what you need to do. There were many times when I first started with Python and the Pandas library where I was attempting to transform data, but I had mixed data types and I wasn't able to complete the command that I was attempting to because of those mixed data types. So a good way to broadly understand what you're working with is when you have a data frame like we have with df underscore list, you can use the .dtypes command, and it will tell you what the data type of your column is. So you'll notice we have object for person and date. That's because they are string objects. For amount, we have int64 because they're whole numbers. And for rate, we have float64 because they're floats. So for example, we intend column 2 to be dates, and Pandas kind of sort of acknowledges that they're dates, but it's not really calling it a date. It's calling it an object. So if you did try to merge it with something that had date time, you might get some issues when you try to transform it. In future videos, we'll be talking about how to transform dates and figuring out how to do more of this data transformation stuff. But for the time being, I think understanding these fundamentals are really important as you attempt to establish a foundation that you build your knowledge base upon. I hope you found this video helpful. Please leave me some comments to let me know what your experience was like, and if you had any suggestions or feedback. I also have my email in my About section, so feel free to hit me up there. I hope you'll check out the next one.